So part B of experiment 7, the goal is to fill out a table, the table that appears on your screen. So we have three columns over here for which the entries are given. This is essentially like filling out a truth table, the input side at least. There is a Q before pulse, and we have been calling that Q previous. There's a J, there's a K, and there's a Q and Q bar after pulse. So that's just after the negative edge of the clock. So if we are asked to experimentally find this out, we actually know the correct answer here because we know the states of the flip-flop, and we have kind of gone through that discussion of the analysis of the JK flip-flop. So we technically we know the answer, the correct answer at least. But the goal of part B is for us to experimentally find that out or validate that. So a few things that can be very confusing is how do I make the Q before pulse 0? J and K, setting them to zeros or ones is pretty straightforward. By using static IO, the ability in waveforms, we can set them as 0 or 1. And we definitely need to configure them as inputs. And Q after pulse and Q bar after pulse, that is just looking at those two output pins using a static IO, and we configure those two as LEDs, for example, because they are outputs. So the key issue that a lot of students get confused about is what is the role of this Q before pulse? So let's take a look at this. We are trying to build this particular diagram here. This is the chip 74107. And just for a quick comment about 74107, it doesn't apply to you, but I just want to make this so that people who watch this video know this. So there are other parts such as 7410 that those are different from 74107. And if you are an EI student, in your paths kit you might find 74107 and you might find 7410. Please make sure that you are using 74107 for the JK flip-flop. 7410 is a 3-input NAND gate chip, which we explored that in part A already. So let's do this. J and K are pin 1 and pin 4 of this chip. Pin number 3 and pin number 2 are Q and Q bar, so those are two outputs. Pin number 13 is active low clear input. So if I want to clear the flip-flop, I need to connect that to ground. So low is active, and I have a negative edge triggered clock that should be going into pin number 12 of that chip. And there are two more connections that are not shown in this view. Those are the power and ground connections. So if you look back at the proto board view, I have made that pin number 14 connection to plus 5 volts, that particular power rail, and I've connected ground on the bottom side to the ground rail. So I've connected the red wire from analog discovery to the top rail and the black wire to the bottom rail here. So pin number 14 and pin number 7 are connected to plus 5 and ground respectively. I just need to turn the supplies on using waveforms. So let's quickly do that. I'm going to turn on the supplies tab, change this to plus 5 volts, and turn this on. I don't need negative supply, so let's turn that off. And let's see here. What else do I need? I already turned on supplies. Apart from that, I need static IO. So I'm going to start the static IO option, and I have 16 static IO channels that are visible in this particular view. So I'm going to have to configure them appropriately because I don't know which pin I've connected to what. So let's see. I have pin 1 that is J input. So I have used yellow to give me 1 second, guys. I'm going to change this. I see. Okay, that should take care of things. Um, all right, we should be back. Sorry about that. Let's see. So pin number 1 is J input, and I have connected all the inputs in yellow, and my outputs are in green color at the very end. However, those yellow and green wires are connected to various different colors from the analog discovery. So the colors are pink and green and purple and brown. So all various colors for the digital I/O pinout. So the way I've connected that is, for example, J, the pin on pin number 1, I have connected that to brown stripe. Brown stripe is channel 11. So channel 11, I have connected that as J. J is an input, so I'm going to change that to a push-pull input switch, which I can go up and down because it's an input. And I'm also going to change the name of this from digital IO 11 to J. Those names will be very, very helpful as I go through this process. Similarly, pin number 4, for example, which is K, I have connected that to digital channel 10. So even this should be configured as a push-pull input. This should be K. The next input, which is clock, pin number 12, I have connected pin number 12 to green stripe, which is digital channel 9. I'm going to make that clock. And then finally I have digital channel 8, which is pin number 13 here. So clear bar actually. So I'm going to change that to clear underscore bar. And both clock and clear are push pull switches. So I can set them as lows or highs. So right now they're all low. For outputs, I have pin number 2 and 3. I have connected pin number 2 to a pink wire, yes, which is channel 0. So pin number 2 is Q bar. So this guy is Q bar and this guy is Q. So they are both output, so that's fine. LEDs are okay. So I've done a few things over here. Quickly recap. I have J, K, clock and Q, clock and clear bar connected to pin number 1, 4, 12 and 13 on the chip, which I have chosen to connect them to channel 11, 10, 9 and 8. You could have selected any 4 from the 16 options. I have connected them in that particular sequence because it's more comfortable for me. And then I've configured them as push-pull switches. Q and Q bar are outputs of the chip, and I've connected them. Those are available on pin number 3 and 2 of the IC, and I've connected them to channel 0 and channel 1 indicated by colors pink and green on the analog discovery pinout, and I've named them appropriately. This If you go in view, there's a show name option, which is extremely useful for this particular experiment. Okay, so this is the starting point. So let's see. After having set this up, uh, should I do something with the clear? Because if I leave clear at 0, what is going to happen? Well, the answer to that is if I leave clear switch at 0, my Q, no matter what I change in J, K and clock, if I have clear bar at 0, my Q will always be 0 because I'm always clearing the flip-flop. So it's probably a good idea for me right now to make this a 1 so that I'm not clearing the flip-flop the entire time. There's a question on the chat box. Let me quickly read this. For the negative edge of the clock, will you just toggle the clock from 1 to 0? That's exactly right, Derek. I'm going to bring the clock up and then down. When I go from high to low, that's when I get the negative edge of the clock. Okay, so let's go down to this table here and let's take a look at the first entry. For the first entry, I need Q before pulse to be a 0. Which it's actually a 0 right now, so that's good. We got lucky there, and we actually didn't get lucky there. We were clearing the flip flop earlier, so we were bound to have Q to be a 0. Let me not clear the flip flop anymore, so I'll make that a 1. I need J to be a 0, K to be a 1. So J is 0 right now, that's fine. K to be a 1. Notice when I changed K, the outputs did not change. They only change, or I should say they have the ability to change only when I have the negative edge of the clock. So I'm going to go up and down. When I go down on the clock, I had the negative edge. However, because I'm in the reset state or the kill state, my Q remains a 0 and Q bar is a 1. So the answer over here for the first row would be a 0 followed by a 1 for Q bar. Now the goal is to fill out this table exactly in the same way. There could be some issues. For example, Q before pulse. For the immediately the second row, I have Q before pulse that I need to set as 1. Now the question is, how am I going to set this as 1 and then go through this row? Because right now it's a 0. Well, if you go back and take a look at the characteristic table here, you have two options in which you can set Q to 1. One is set the flip-flop or jump the flip-flop or toggle the output, because right now it is 0, so I can toggle it to a 1. So let's do the toggle. How do I toggle? I need J and K to be 1 1. Okay. Then I need to provide a negative edge of the clock. So I go up again and down again. When I do that, Q toggled from 0 to 1. And just for fun, let me show you what happens. If I leave J and K at 1 1 and I keep cycling through the clock, it will keep toggling. As you can see, it keeps toggling. As long as I don't clear the flip-flop. The moment I clear it, the Q goes to 0. So I need this to be a 1 so that I'm not clearing, and I needed Q to be a 1 before pulse. So I'm going to do that. Next, I will go down to the table. Q before pulse is set to 1, so that's good. J should be 0. Right now it's at 1, so I'll change that. K should be 1. It is 1. So in order for us to find out Q after pulse, I will do the toggle of the clock again. So up and down. Once I do that, Q has become 0. Of course, that's what I expected because we are in the reset state currently. And Q bar is 1. And the same process I need to apply and go through all the 8 possibilities over here. So that's how we work on part C of experiment 7. Let me take your, well, let's stop the recording here and I will take your questions.